Hi everyone, welcome to Coding Inspired. This is Abdul Mateen. In this video, we'll be taking a look at binary search algorithm. The time complexity of this algorithm is order of log n and its space complexity is order of 1. At the end of this video, we'll be implementing the algorithm in C# programming language. First, let's take a look at why we need a binary search algorithm when we already have a linear search algorithm. When coming to linear search algorithm, we search the element one by one and we compare it with the key or the item you're looking for against the values in the array, and if we find a match, we're going to return the index of that particular element. The problem here is, suppose the array is of very large size, then we have to go from the 0th index and maybe to the 1000th index if the element resides at the 1000th place. So it's going to be taking a long time as we are iterating each and every element from the beginning of the array till the end of the array. So it's not very optimized when we want to do faster calculations. That's when the binary search algorithm comes into picture. So how the binary search algorithm works, initially we'll be taking a very simple example to find the key 7 in this array that we are having. So here we can see an array and where we have 0 to 7 indices and the elements are 1, 2, 4, so on till 15, 23. So we need to find the element 7 in this, and we need to return the index of the element 7. So how we do that is, in binary search, we are going to be taking two pointers, that is left pointer and right pointer. The left pointer initially starts off at the beginning of the array, and the right pointers initially starts off at the end of the array. And we are going to calculate or find the midpoint. A midpoint is anything like a place where both left and right pointers are going to meet. So what we basically do is we sum up left with the right indices and divide it by 2, which gives the midpoint to us. So here in this example we can see the midpoint is equal to left plus right by 2. So left value is 0 and right is 7. So we have to sum the indices and not the elements here, and we have to divide it by 2, which leads us to 3.5, and we round it off to 3. So at the index 3, the element 7 lies. So we have found the element we were looking for. So when we consider the same example in linear search algorithm, it will take 4 checks, or 4 times we have to loop. So order of 4 would be the optimal solution for that, but in this case order of 1 is the best case scenario. So we right away found the element we were looking for. So this is how basically the binary search algorithm works. So the main parts of this algorithm are finding the midpoint, that is left plus right by 2, and if that is not the element we're looking for, we either move to the left side or right side. So this is a divide and conquer algorithm. So we refine our search into the left subarray or the right subarray based on the value. Suppose we are looking for an element greater than the midpoint, then we check in the right subarray, otherwise we check in the left subarray. Let's take a look at those examples now. So let's consider we are looking for the key 12. So what happens is we found the midpoint. The initial midpoint is 3, but the element 7 is less than 12. So we need to look at the right subarray, and the right subarray is formed by updating the left value as mid plus 1. So what we do is we move the left pointer to one place one place in front of the mid value. So mid value was 3 plus 4, 3 plus 1 is 4. So we move the left pointer to the 4th position, and we are going to calculate the midpoint again. So this time the midpoint is 5. So that ends the search here. So we have found the element 12 that we were looking for, and it's done. Now consider this example where we're looking for the key 4. So it starts off initially in the same way. We find the initial midpoint when left and right pointers are at the edges or at the boundaries of the array. So the midpoint is 3 when 4 is less than 4 is less than 7. So we have to look for the element in the left subarray, and we do that by updating the right pointer with the value of mid minus 1. So mid is 3 minus 1 is 2. So now the new right pointer comes to the second position, and now we're going to calculate the mid again, which leads us to the midpoint of 1, but 2 is less than 4. Then we are going to move the left pointer now. So what we do is we update the left pointer with mid plus 1. Now what happens is both the left and right pointers come to the same position because mid was pointing at index 1. 1 plus 1 becomes 2, so left has become 2 now. So now we're going to calculate the mid again. Now that leads us to the output of 2, and we check whether the element at the index 2 is actually the element we're looking for, and yes it is. So the search algorithm ends and we return the index of the element. Now let's consider an example of 20, which is an element that is not in the array, and we are going to be searching for it. So let's consider this case and evaluate how the algorithm works. Initially we start off at the boundaries of the array. We find the midpoint. So 20 is greater than 7, so we search in the right subarray. The left pointer updates with mid plus 1 value, and it moves to the position that is 4th index. And now we calculate the mid value again. So mid value is 4 plus 7 by 2, which is 5. 5, that is 12. 12 is less than 20. Even we have to go further and divide the array into more number of parts, as we are requiring to do that. So we are going to form a new right subarray by updating left with mid plus 1 value again. And now the new left pointer comes to the index 6. We're going to calculate the mid again. Now the midpoint is again 6. So what we do here is we move the left pointer again because 15 is less than 20 and we have to step ahead. So we move the left pointer with mid plus 1 value, and it goes to the index 7. Now left and right pointers are at the same spot here, so we are going to be calculating the mid again, which is 7. So what's we need to take a look at here is the value is 23, which is greater than 20. So we are not at the right place, so we need to look at somewhere behind this element. So what we need to do is we need to look in the left subarray. To do that, we have to update the right pointer. So we update the right pointer with mid minus 1. What this does is it takes the right pointer at the 6th index. So this is what happens. But now this is a special case which should be treated as the exit condition of the algorithm. So in case we search for the element or the key but we were not able to find, and we need to have a condition to terminate the algorithm, otherwise it might go in an infinite loop or infinite recursion, leading to Stack Overflow exceptions. So when left and right pointers have crossed each other, that's when we need to abruptly terminate the algorithm. So this is the case that we need to always ensure that we handle it. So let me head over to Visual Studio so we can code the algorithm there. So first things first, let me create an array. So the elements in the array are 2, 4, 1, 2, 4, 7, 12, 15, and 23. So this is an integer array. Let me just ensure the numbers are correct. So 1, 2, 4, 7, 10, 12, 15, 23. Alright, I just missed 10 there, so I have put it. Now we're going to write a method that will perform the search, and it is going to take left and right pointers. The left pointer in the initial step is going to be 0, as we will be starting at the boundaries of the array, and the right pointer will be the array of length -1. And we need to search for a key, so I'll be taking the key from the standard input. Let me ask the user to enter the key. Enter a key to search. And I'm going to parse it. So we have the key, and now we'll be implementing the algorithm. We'll be taking our input array, the left pointer and the right pointer, and the key that we're looking for. As it is supposed to be returning the index, we'll also print the corresponding output if we found the element and if we don't find the element. In case when we don't find the element, we say let's say key not found. Otherwise we say key found at, so we say key and index. And we're going to just wait for the program instead of abruptly terminating. So, and coming to the algorithm, let's implement it. So first we need to write our exit condition, that is left should be less than or equal to right. If this is not the case, we are going to return -1. Here we'll be finding the midpoint, which is left plus right by 2, and we need to check if the element at the midpoint is the actual element we are looking for. So we say array of mid is actually equal to the key. If it is, we are going to return the midpoint, which is the index of the element we are looking for. Otherwise, what we do here is we check if key is actually greater than the midpoint. If key is greater than midpoint, then we have to search in the right subarray. We do that by updating the left pointer with mid plus 1. If this is not the case, then we have to search in the left subarray, which we do by updating right as mid -1. So that's pretty much the iterative approach for binary search. Now let's test it out. So I'm executing the program. Let's search for 7, 4, 12, and 20, as we have seen. So first we'll be searching for 7. So it's found at index 3. 0, 1, 2, 3. That's correct. Now let's run it again and search for element 4. But 4 is there. Wait, why isn't it working? Right equal to mid -1, left equal to mid plus 1, return mid. If alright, so this is an iterative approach. I just forgot and this should be a while loop and not an if statement. While left is less than right, we have to keep doing it. Sorry for the glitch, folks. So let's take a look at first. For 4, it's found at index 2, 0, 1, 2. That's correct. And let's find the element 12. So this element is also found at index 5. That's correct. Let's take a look at for element 20. This key is not found. Let's even search for 30. This key is not found. Let's search for -2, negative element. This key is not found. So our algorithm is working fine without any exceptions or array out of bounds exception. So now let's take a look at a recursive approach also. Binary, sorry, I spelled that right. Recursive approach. So the parameters are same for both iterative and recursive approach. So I'm going to be calling the recursive version here. I'll return -1 if nothing is found. So here what we do is we have to make sure left is less than or equal to right. I bet I'm keeping the condition correct this time. Because this is a recursive, we won't be using the loop here. So if left is less than right here, what we do is we get the midpoint, mid equal to left plus right by 2. And here next what we do is we have to check whether array of mid is equal to key. Array of mid is equal to key. If it is, return mid, because that's the element we're looking for. If it isn't, we're going to check whether key is greater than array of mid. If key is greater than array of mid, we have to look into the right subarray. And the way we do it, we recursively call binary search algorithm again, pass in the array. As we have to look in the right subarray, we have to update the left pointer by mid plus 1 and say right and send in the key. Otherwise what we do is binary search by passing in the left pointer here, and it's going to be mid -1, and we pass in the key. So that's basically it when it comes to the recursive algorithm. In this last case, if the key is not greater than the element at the mid position, so we need to look into the left subarray, and we do that by updating the right pointer to mid -1, and recursively this value will be passed into the right parameter here, and so forth. This algorithm is going to perform, and in case the exit condition is met, we'll be returning -1. So let's test this out with the same inputs that we gave earlier. We'll be looking for 7, it's found at 3. We'll be looking for 4, found at 2. We'll be looking for 12, found at 5. 20, not found. So let's take a look for 30, not found. Let's search for -5, not found. So our algorithm is working fine without any errors or exceptions, and also we are checking the boundary cases by writing the exit condition here. So this is how we perform binary search, and this is the code for C# implementation. I hope you guys have liked this video and hope it was informative to you. Please subscribe to this channel and leave a like and comment on this video, and share this video if you liked it, and dislike this video if you disliked it, and please share your feedback, why you disliked it or why you liked it. I'll be really happy to hear out what you guys have to say. And thanks for watching. I'll see you guys next time. Take care.